start now. Okay, so here we have another set of examples for which we need to find the antiderivative. Okay, so antiderivative of sums is sums of antiderivatives here. We are trying to find antiderivative of sine x. What is the function whose derivative is sine x? Well, you may say the cosine x, but derivative of cosine x is minus sine, negative sine x. I don't like that negative sign, so that's why I have to put an extra negative sign to get the right antiderivative. So antiderivative of sine x is negative cosine x. Antiderivative of e to the power x is e to the power x minus 4 times, this is x squared, this is x to the power 2 plus 1 over 2 plus 1, and then plus c. That is the antiderivative of the function. Okay. When it comes to the antiderivative, so remember the derivative of e to the power x is e to the power x. So antiderivative of e to the power x is going to be e to the power x. So this is antiderivative. But if I have e to the power nx, what is the function whose derivative e to the power nx? Well, you may say it is e to the power nx, but remember that when you find derivative of e to the power u, it will be u prime e to the power u. In this case, the derivative of e to the power nx will be n e to the power nx. Just to get rid of that effect of n multiple, we put 1 over n to make sure that we are good there. So here now, the antiderivative of e to the power 3x is going to be 1 over 3 e to the power 3x plus antiderivative of e to the power 3 times x. So you have to be careful here a little bit. This guy is a constant times x. So the constant, you can write it there. X is x to the power 1. Use the power rule for the antiderivatives, and that will give me this piece here. Plus, what is the function whose antiderivative is sine inverse of 0.3? I don't know what is sine inverse of 0.3, but this guy, the whole thing is just a constant. As if it is 2, 10, I don't know, 1,000. Antiderivative of any constant is that constant times x. And then you need to add c to the whole thing. You look at this function, 5 secant x times this whole thing. So as the quotient were, the antiderivative of quotient was difficult thing to do. In general, we don't have any rule for the antiderivative of quotient. For the products, the same thing goes for the product. So product of the thing, I don't know, we don't have general rule for that, but we will try to expand it and see if there is anything good we can do there. So this will be 10 secant x times secant x, this is secant squared, minus 5 times 3 is 15, secant x tan x. Now, do I know what is antiderivative of secant x? Well, remember, the derivative of tan x was secant squared. Now, antiderivative of secant squared is tan x plus c. Also, the derivative of secant x itself was secant x times tan x. So antiderivative of secant times tan is secant and then plus c. So here, then antiderivative, use the sum and the difference of antiderivatives and constant multiple rule. You get 10 times antiderivative of secant squared is tan x minus 15. Antiderivative of secant x times tan x is secant x, and then plus c. What would we do with the x squared over 1 over x squared. Something that you should remember, the derivative of tan inverse x was 1 over 1 plus x squared. But what that means, what? That means that 1 over 1 plus x squared, the antiderivative of this function is tan inverse x plus c. Here, I don't have 1 over 1 plus x squared, but what I can do is that I can add 1 to the numerator and subtract 1 from the numerator. This way, I will have this a little bit longer fraction, but then I can separate x squared plus 1, the domain for x squared plus 1, and 1 over there, yes? But these two guys cancel each other. This is 1 minus 1 over 1 plus x squared. Antiderivative of 1, I know, is x. And antiderivative of 1 over 1 plus x squared, we just had that. This is tan inverse of x plus c. So sometimes you need to do some steps of work to turn your function to a function you can find its antiderivatives.